Do you hear me? Oh, let me check it. Test. The Discord said I'm okay. And also, if you switch on the speaker on the YouTube video, it should be. Oh, thank you very much. Alright, where we stopped. So what is, for example, pi 1 over s? Pi 1 over s means it takes pi, if it's a constant, omega constant angular acceleration, every second it moves a half of the full circle. But since this is not a constant angular velocity motion, what is beta t? Beta t is nothing else, just omega t derivated. This is pi. Pi 1 over s square means in every second it increases the angular acceleration with pi. So in the 0 it's pi. In 1 second it's 2 pi, in second it's 3 pi, and so on and so on. That was the easy way. If we know the theta t, we can calculate omega t and the beta t. Let's solve the other way, what you can see there. For example, I know at theta t equals 0, I'm at pi. Oops. My initial angular velocity is pi over 4, and there is a constant acceleration which is pi over 2, 1 over s square. What is the theta t? Alright, so the omega t is the omega t equals 0 plus the integral from 0 to t, the beta. This is what we call delta omega t. You can see the delta omega t in this case. So this is pi over 4, and this is pi over 2t. What is the theta t? The initial position plus from 0 to t, the omega t, which is this one. This is what we call initial for theta 0, and this is the d theta t, how the body changes its position by moving with non-zero omega t. The theta t in this case, it was pi plus we have a pi over 4, so integrating this part, pi over 4t square plus pi over 4t plus omega. And now we can again ask where is the body at, for example, t equal 4. So at t equal 4, pi over 4, 4 square plus pi over 4, 4 plus pi, this is 4 pi pi, it's 6 pi. In other words, it's 3, let's say, full rotation, or full circle. So the answer is the body here, but after moving 3 times. So technically it started from here because at theta equal t it was at pi. So let me draw again. At t equal 0 it was here, and then 1, 2 and 3, and this is the t equal 4 second. And of course I can ask anything, so what is the omega t equal 4 second? With that I can use its formula. It's pi over 2 times 4 plus pi over 4, which is, this is 2 pi, so it's 2 pi, this is pi over 4, this is 9 pi over 4. Alright, so you can show me how you can solve that example. Let's say same story, but instead of pi over 2 in beta, let's use pi over 4. So tell me, where is the body at 4 seconds? And how many n times? Full rotation plus something. I will give you 5 minutes for that. Alright, thanks. Let's have for the others if they have problem with it. So the omega t will be omega t equals 0, which is pi over 4 plus 0 to t the pi over 4 dt, which is pi over 4 plus pi over 4 t. The theta t will be pi plus 0 to t pi over 4 t, plus pi over 4, which is pi over 8 t square plus pi over 4 t plus pi. At t equal 4, this is pi over 8 4 square plus pi over 4 plus pi, which is, this is 2, this is 4, 2 pi plus pi plus pi, that's 4 pi. Thanks. Your answer was correct. I think that should work. Since you've seen this presentation, I won't go through it. Just some remark, for example, let's keep the omega t. Angular acceleration, perhaps you remember, so even at the constant angular velocity, there must be acceleration, since the velocity is a vector and the velocity changes since it goes around the circle. There is a so-called centripetal acceleration. Its formula is the v square over r, but by the nature of the circular motion, the v equal omega times r, so it's omega square r. Let's say the radius is 1 meter, and let's look at the body. If it moves like this, the omega t equal 0 is pi over 4, so the centripetal force is pi over 4 squared times 1, which is, well, it's 0.8, 0.5, it's a small value. Let me double check, I don't want to write. Oh, by the way, I also sent you the link of my table, so you can log in and you can also download my screens. The streaming, I had some problem with the streamer. Well, I think it works. Alright, which is 5 pi over 4, 1 over s. In this case, the centripetal acceleration is times divided by 4. Omega square r, which is 15.4 meter per square. So the faster the higher you have the angular velocity, it will continue with the square function, how the centripetal acceleration increases. Here's some example, and I think next time we will practice the work, but I think we did, I mean, at least one of the group had some practice with work. Let me check the lecture 7. Can you remind me, have we solved such an example, how the kinetic energy goes to potential and backwards, or springs? All right. All right. There are some problem with the internet in my office, so I think that's all for now. And next time we'll solve energy, potential, and work examples, because that's pretty different. So I don't know when and how we rewrite the. Oh yes. For example, this session for the Smart Cup also ends. Yes. All right. So try to present the grades of your last test. And by the way, worst case, we won't write any second test. But for example, in the final exam, I will give you also examples from the circular motion and from the topic of energy, potential, and work. So I have to restart something in my office because everything is off except this Discord and the YouTube channel. Let's meet next Wednesday and Thursday, and of course on the lecture next Monday. So you can type questions, what I see somebody is typing. I stopped the streaming because it's